Hey physics. So we've been looking at acceleration and how unbalanced forces cause acceleration. So now I wanted to show you what different kinds of acceleration look like on a graph. So notice on these graphs that this is not a position time graph, this is a velocity time graph. So this is how much is the speed changing over time. Okay? So when we look at these flat line graphs here, that means that the velocity is just staying constant. It's not speeding up or slowing down. It might be holding totally still as it is at this line, or it might be going, say, like 4 meters per second, but consistently 4 meters per second, or it might be going like 8 meters per second consistently. And when we are in the positive here on our velocity time graph, then they're going forward, okay? So going forward at a consistent 4 meters per second or a consistent 8 meters per second, okay? If we are looking down here at the negative side, I want to make sure you guys can see that negative sign there, then what that means is that they're going backwards but at a consistent speed, okay? So I want you to see this plus and this negative and think, well, hold on, let me just explain this a little bit more step by step. So we had 4 meters per second in a forward direction for number 2. We have 8 meters per second in a forward direction for number 1. So then for number 4 here, we are looking at negative velocity. And when we're talking about positive or negative in terms of velocity, we are talking about a forward or backward motion, okay? Positive is a forward motion, negative is a backward motion. So when we have this constant velocity here staying the same speed, this could be negative 4 meters per second, so moving backwards at a rate of 4 meters per second consistently, that's what that straight line says, or negative 8 meters per second, moving backwards consistently a bit faster, but again at that consistent rate. So this is where it gets fun, because this is where we're thinking about acceleration. Constant velocity over here, this is a change in velocity, which as you guys know means acceleration, deceleration, or negative acceleration. And all of those mean a change in velocity. So if you look at number 6 and number 9, they are both starting at 0 meters per second, miles per hour, whatever that is. So they're starting from no movement at all, and they are going to they're speeding up, right? If you think about what the numbers on this graph would look like, we could say this is like positive 10 meters per second, and this is negative 10 meters per second. So either way, we have a lot of movement, a lot more movement the farther away you get from 0. Let me pause this video real quick and put those arrows in there so you can see what I'm talking about there. Okay, so I added some arrows. I put my hair in a bun because we're going to get into this. So basically, like I was saying, as you're at 0 velocity, then there's no movement. As you get farther away from 0 velocity in the positive or negative direction, it means there's more movement, okay? So looking at 6 and 9 here, they're both starting at 0, and they're both going like really fast, right? And then same thing here, but just backing up, right? So 0 miles per hour, and then right, so super fast by the end. So then we look at 7 and 8, and those are starting at a higher velocity. They're starting at maybe 10 miles per hour, 10 meters per second, and they're going down so it's not a direction thing. The number of their velocity is decreasing, meaning they're slowing down, right? So they're starting off at like right? Stopping there. Or they're starting, this is still moving backwards. Now this is where, like in my brain, it's hard because I'm thinking about position, but it's not their position, it's how fast they're going for this one. So, so they are backing up, really, they're going fast at a backwards rate, and then they're going forward. So I'm going to use this car here to show you guys what each one of these lines would look like real quick. So here we go with 0 velocity. That's what it looks like. That's what it sounds like. So if we have a forward velocity that's kind of at a medium rate but consistent acceleration or consistent velocity, we're going to go right? If we have this higher velocity that is consistent, it's going to be like right? What if we're going backwards? So we had our 0 velocity. We can start over here and have 0 velocity also. So there's our 0 velocity graph right there. So then now we're going to go backwards at a reasonable pace, but negative, going backwards instead, and consistent velocity. So like that. And now we're going to go backwards at a slightly faster pace, but not changing velocities, just going backwards. So like that. That is number 5. So now I'm going to show you these graphs and what that would look and sound like. So I did not think when I became a physics teacher that I would be doing so many car noises, but it's good. It's good. You guys love it, I'm sure. So, okay, so I'm going to start with number 6. So starting at 0 miles per hour and getting faster in a positive direction, okay? So, right? That's what that one sounds like. Let's do number 9. We'll start at 0 velocity, and we're going to speed up going backwards, speeding up in the negative direction, going backwards, okay? So, okay, so the motor's on, right? Like backwards like that. That's what that one's doing. Okay, so then let's look at 7 and 8. So with 7, we are going in a positive direction, going away from the starting point, but we are slowing down. Our velocity is getting less, okay? So starting fast and getting slow. Like that. And it didn't entirely stop, but that's what you can see there. And then this one would be starting off in that negative direction. And so not, sorry again, it's not position that is determined by the positive and negative here. It's how fast you are going. So we're starting off going fast in a negative direction and slowing. This is number 8 here. Okay, so like that. You're welcome. I'm sure this was an enjoyable video for all of us. So I hope that helps you to understand what's going on here.